Hi, welcome back. Now, today we're going to discuss about this. Um, you can say that it's a trigonometry complex number analysis, right? Okay. Now, show that this trigonometry can be written in its double angle identity, right? And then B, we're going to use this standard relationship between the right-angled triangle to further prove or obtain the similar identity for cosine 6 theta. And then using the result from A and B, we are going to summarize the integrations of these trigonometry functions with respect to theta. All right. Okay, let's take a look at how to start with this. So A. Now, first of all, we will start by using the standard result that we have set up, and then with the help of Demoivre's theorem. So that is, we know that z. Okay, should I be using this? Okay, no, I shouldn't be using this. I should be using this instead. All right. So this to the power 6 is basically the same as I sine theta because z minus 1 over z. Now I need to make one remark here. Okay, so where the z is actually cosine theta plus I sine theta. All right, now that's the remark here. Okay, now this would actually give us what we have is this is actually 2 to the power 6. Now also know that the I square is actually equal to -1. So therefore this is the same as I6 sine 6 theta. All right. So you can see that. And then knowing that this one will be 64 here, of course. And then this part here, I6, we can actually write down as I square to the power of 3 then sine 6 theta, then that will be easier. So from here itself, we know that I squared is equal to -1, therefore that is -1 to the power of 3 then. So therefore that will be -64 sine 6 theta. All right. So now that's the first step. Then the second step, we are going to apply the binomial expansions for this expression here. So that will be a z6 minus of, let me see here, that will be a 6 z5. Uh, yeah, z5 is actually a plus -1 over z. Right, so let me see. I can't really remember the factorial number, so I'm going to try to recall the Pascal triangle. So that should be a 15. Okay, so that should be a 15 z4 here, -1 over z to the power of, because the total must be equal to 6 here, so it must be to the power of 2. And then after that, I will have 20 z, is it 20? Okay, what happened to my 20 there? Just let me, it feels like there's an accident with a 0. So 20 z3, a -1 over z to the power of 3. And then after that, I have 15 z square, -1 over z again to the power of 4. And then after that, I have, did I get it right? Okay, sorry. This one is supposed to be 20. I think I mistaken this number here. So it's supposed to be 20. This is 15 z, -1 over z to the power of 5. And then finally I will have my negative z to the power of 6 there. All right. So from here itself I can simplify this, so that will be like 6z4, and then I will have a 15z2, and then what I have here would be a 20 plus 21 over z square, and then I have my negative 20. Oops, why there are so many 20 there? 1, 2, this is z squared. Okay, this is 15. I always copy 20 there. Okay, there will be a 15 um 1 over z4, and then finally I have my z6 there. And then I'm going to group all the z6 together. So z6 plus 1 over z6 there. And then I have my, what else did I miss out? Why do I have a 6 here? Let me see if I have a 6 here, and therefore there should be a 6 at the end. And let me see, this is 6, 15, 20. How many terms do I have? 1, 2, 3, 4, 5, 6, 7. Yeah, 7 terms. That is correct. Okay, so the first term is 6. That is correct. This is 15. Okay, now this is my mistake. This is 15. This is a 6. Yep, now this is correct. This is 15. Okay, so do check. I made a mistake on this part and this part here. All right, so that should be 15, 15, 20, 60. So therefore, because of my mistake, I need to change this to be, I have a 20 there. This is 15. This part is a 6. Okay. So this is 15, this is a 6. Right, now we are good. Right, now after that we will have a 6 z4 plus 1 over z4 there. Okay, and then after that we have our 15 z2 plus 1 over z2. Okay, what else do we have? We have done, so finally we have our 20 there. And then there's a standard result for z6 plus 1 over z6. Okay, so the zn plus 1 over zn is actually the same as let me see, 2 cos n theta. So this is the standard result that we will get. So from here we will get a 2 cos 6 theta here, minus of a 12 cos 4 theta, and then this one will be a 30 cos 2 theta, and then minus a 20 there. And then there you have it. So which means indirectly, because this is the same as this, so therefore negative 64 sine 6 theta must be equal to this. And then therefore we can conclude that sine 6 is actually equal to negative 32. I think all of them you can factorize out the 2 there, so therefore that will be 6 cos 4 theta there, and then this is 15 cos 2 theta, and then finally you have a 10 there. And then therefore that conclude our proof. Let me check whether I got it correct. And 6 is it 10? Yep, correct. So that's the first one, right? So I hope that's clear. Now the second part, I'm going to pause here and then work with the second one shortly. All right, this is our previous result. I'll just rewrite that again. We have this. I just copy it directly from here. This is what we got just now. Okay. Now, of course, here we still make the assumptions that z is actually equal to cosine theta plus I sine theta, and then having I square, which is an imaginary number in this case, equals to negative 1. All right. All right. Now we can first use the substitution. Let alpha be equal to pi 2 minus theta. So we can actually substitute this into here. All right. So, or in this case, you can say that indirectly the theta itself is actually pi over 2 minus alpha. So we can substitute this one into here. We have pi 2 minus alpha, which is the same as 32 cos 6 pi 2 minus alpha here, minus cos 4 15, and then finally we have 10 there. Okay, so this is what we have, and then we know that the sine sine theta, or in this case sine theta for this. Okay, let's just let me write it down. Sine theta for this is basically equal to cosine alpha. That is its complementary relationship. So from here we can actually write this one down as a cosine 6 alpha. This whole thing is actually a cosine 6 alpha, which is the same as this. All right, and then what we have now would be, okay, now that would be a 3 pi minus 6 alpha cos 2 pi minus alpha. That will be a pi minus 2 alpha. All right, so that's what we have. And then from here, there is also a relationship that we can explore with. Okay, now we know that cosine, I'm going to write this one down. Cosine 3 pi is basically the 2 pi plus pi minus 6 alpha here. Okay, and then this one here is easier. Okay, we know that that one must be the same as, I think I missed out the 4 here. Let me correct that. So there should be a 4 alpha. So this is the same as 4 alpha. And then now this one here we have to be mindful a bit, because pi minus 2 alpha, if you apply the double angle identity, you would get a negative cos 2 alpha there. Right? Okay, so this is what we have. And then from here itself, this one will be the same as, all right, so this one will be the same as again, this one is the same as cos pi minus 6 alpha, but it's actually a negative cos 6 alpha. Cos 4 alpha minus 15 cos 2 alpha minus 10. And then of course, if we try to simplify that, taking out all the negative, it will be 1 over 32 cosine 6 alpha plus 6 cosine 4 alpha plus 15 cosine 2 alpha plus 10. Of course, if you let this is just an arbitrary symbol variable that we use, so therefore you can conclude that if I change it to theta or any other symbol itself, therefore we can conclude that cosine 6 is the same as 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10. Right, so that will be the identity for cosine 6 theta there. So I hope that is clear at this point. Okay, right. Now, of course, there's another way to prove this, also using the same complex number. Right, now I'm going to show it to you shortly. Right, now the second way to prove or to obtain the similar identity for cosine 6 theta is by using almost the same procedure like how we obtained the first expression here. So in this case, I'm going to make use of z plus 1z 6 instead. So since this is a summations of these two complex number, now of course I'm making assumptions, or I'm making this notation. The z represent a complex number, can be written in this form, where my I square again is a -1. All right, and then this is a complex number. Okay. All right. So from here, this one will give us a 2. So 2 cos, right. This one will be a 2 cos theta to the power of 6 here. Right. And then that would be a 64 cosine 6 theta. Right. Now this one will be much more easier. Now then again, for this part here, we can proceed on with the expansion. Now we will know that since we have obtained the previous expansion, this one will be z6 plus 6 z5 1 over z plus, okay, let me see whether I still remember the term or not. It's 15 z4 1 over z square plus 20 z3 1 over z3 15 again z4, and then I will have 6z z5 here, and then finally I'll have my z6, right? So from here, as usual, I can group this, so I'm not going to show the term anymore, so I can group this with one term, and then I can have z4 as one term here, so you can see z4 and z4 here, 15 as a z2, and then 20 is just left alone. Now that will be just 20, and then by using the same result that we have obtained, so uh, here we can actually write down 2 cos 6 theta plus, again, this is a 12 cos 4 theta plus 30 cos 2 theta plus 20 there. And then we know that this expansion is the same as this, so that will be 64 cosine 6 theta there. And then we can conclude that from here, cosine 6 theta is the same as 1 over 32 cos 6 theta plus a 6 plus a 15, and then finally is a 10. Alright, so this is the same result that we obtained by using this complementary identity. Right, now I hope that is clear. Next, we're going to bring forward these two results, the first result here and the second result here, to work out the integration here. Right. Okay, so I have rewritten both of these results that we obtained in A and B. You can see that this is what we have. Okay, okay, this is what we have at this point. Okay. Now, what we need to work out now will be the integrations for this. First of all, the cosine 6 theta plus sine 6 theta here is basically the equation number 1 add up with equation number 2 here. So if we add up these two equations here, we will get the summation of this. And then by adding this up, we will only end up with 1 over 32 here. Okay, so we have a 12 cos 4 theta. Okay, is that correct? Let me check. 132. This one is 12. Yeah, correct. And then after that, we will have the 20 here. Yep. So that's what we have. And then, of course, you can simplify that. Take for instance, we take out a 4, then 1 over 8. 3 cos 4 theta, 4, 5. Okay. So that's what we have. And then in order to integrate this, so integrating this from 0 to a is the same as integrating this from 0 to a also. And then that would yield the 1 over 8 3 over 4 sine 4 theta plus 5 theta there, from 0 to a. And then that will be quite direct from here. We know that this result here is basically 1834 sine 4a plus 5a, because the other result is a 0. Okay, now given that this integration is equal to this, so therefore 1834 sine 4a plus 5a here is equal to 5 pi over 32. And then if I were to simplify everything, I would be able to get this, at least I would say. Okay, so if I were to multiply this, that will be a 420a equal to 5 pi. All right, now this is what we have currently. All right, now this is a very good equations to solve, I would say. Okay, now what happened is that there are, at this point of time, you may thought that there are many solutions to this, yeah, including myself also. When I solve this, right? When I see this for the first time, I thought that, well, maybe we can use numerical solutions to this. Yep. But the problem with numerical solution would be I have no idea what is my A. So therefore, I will need to find another way to figure this out. Right? Now, one of the methods here is usually in the exam, they prefer to check, even in math Olympiads also. I would say that they tends to study the property of the curve. Okay, so we're going to solve this shortly. I'm going to solve it over here, right? Okay, so I'm going to pause here for a while. I'm going to erase all this, and then I'm going to solve this step by step here. All right, so one way to check whether this is an increasing function or whether it's an oscillating function. Initially, my thought was, since it consists of sine, it might be oscillating. So if you are not sure, like me, I'm not sure. So I'm going to verify whether this is oscillating, whether this is increasing, or whether it's a decreasing function. So I'm going to rearrange all this. I can write down as sine 4a plus 20a minus 5 pi equal to 0. And then therefore I will let this as a functions of a, for instance, which is 3 sine 4a plus 20a minus 5 pi. And then I'm going to do a bit of calculus work here. So I'm going to differentiate with respect to a. Now that would give me a 12 cos 4a plus 20. All right. And then now from here onwards, I can actually check whether this first derivative is fluctuating, or is it greater than 0, or is it less than 0 there, right? Now, first of all, I can actually verify this very quickly. This is actually greater than 0. Greater than 0 because, oops. All right, now I would say because the main reason is because of the range. The range for this 4a fluctuating between a 12 and a negative 12. Right. So because the range is here, therefore the lowest you can go is a negative 12. Even if it's negative 12, that will still be a positive. If it fluctuates over the upper boundary, which is the 12 itself, then therefore there will be a positive. Here we will notice that the gradient of this function is always positive. Therefore, this is an therefore we can conclude that FA is an increasing function. Now, since it is an increasing function, and then if there is a solutions to this, if there is a solutions to this, there can only be one solutions. if there is a solutions. Okay, now I wouldn't say if there is a solution. And then in this case, um, because the A is served, I would say in this case the Y value, you can see that the Y value most probably would be, okay, now let me see if I have anything. This is 0 to A. I assume that A must be larger than greater than 0 then, so I assume that A must be greater than 0 in this case. So since A is greater than 0, therefore, okay, therefore, uh, even if you subtract off this 5 pi here, okay, that will still be uh, f- that will still be larger than this value here, because even if you have the lowest value for this, for instance, a 1, for instance, okay, this FA will still be greater than 0. Okay, if you try to put in the lowest value here, -3, and then the lowest value here would be, oops, I shouldn't make that conclusion at this point, because it's possible that it could be less than 0. Hold on, just let me correct that. All right. Sometimes when you do this for the first time, yes, these are all the wild thoughts that you might be having. I don't really have any analysis tool to help me to confirm that. All right, so now I'm going to try to analyze it further so that we can see. Okay, so for these sections, we know that the fx, it must be an increasing function, and then the range for FA, it could be a negative number. You can see that it could be a negative number. As I said, if this sign go very negative, right? So very negative, and then if you assume that A is a very small number, okay. I think if this is greater than 0, now we can assume that this could be 0.1, maybe the smallest one here. Okay, so therefore it could be a negative number, and then it could be a very positive number also. So therefore this typically cover, I would say at this point, it's safe to say that the range for this is or are all real numbers. Yeah, that will be more accurate. They are all real numbers. So since they are all real numbers, and then fx is an increasing functions, therefore it will only cut the y-axis. If I were to draw this graph here, FA then. Now the graph most probably, because it ranged from negative value up to positive value here, and then is ever increasing function. Therefore, there's only one chance that it will cut through the x-axis at one point, which is actually our solution. So the only solution. Right? Now that is the small tiny analysis that we need to know. So therefore, yes, we can conclude that there's only one solution there. But what will be the solutions? Yep. Okay, what will be the solutions? We will have to figure this out then. Okay, so now therefore there are many ways to do this. Okay, now this is what I've learned today. Okay, now even in math Olympiads also, they always use this trial and errors technique. If you can, it doesn't always work. All right, trial and error. If it works, congratulate. Right? If it doesn't work, you have to find another more systematic methods then. Right? Now for these questions, we can use trial and error. So now, anyway, I already knew the answer. So I'm going to pretend that I'm actually carrying out a trial and error. So A is equal to pi over 2, for instance. Okay, if you try a equal to pi over 2, for instance, then therefore your FA in this case, your FA would be 3 sine 4 pi over 2 in this case, plus 20 pi over 2 minus 5 pi in this case. And then now from here itself, this is a 0, this is a 10, this is a 10 pi. Yep, correct. So this is the 10 pi. This is a 10 pi. Yep. Is it pi over 4? Yep, correct. So this is a 10 pi minus a 5 pi, which yield a 5 pi, which is not a 0. So therefore A is not a solution, of course. And then you must know that the A must be positive because we are integrating from 0 onwards. So therefore, typically the A would be greater than 0 then. Right? So that's the reason why we make this assumption here. Then you can try another try error, which is pi over 4, for instance. Right? So therefore, you can try out pi over 4. In this case, that will be okay. And then surprisingly is actually equal to a 0. You can see that from here, there's a difference of 5 pi. If you try to make this assumption here, yeah, it would yield a 0 here. Right? So maybe it's best if I write it down here for our second assumption, our second try error. All right. Okay. Now I hope that is clear. So from here, because there's only one solution, and then through trial and error, we found that A is equal to this. Therefore, the exact solutions to this must be equal to pi over 4. Sorry, this is pi over 4, not pi over 2. So pi over 4 here. All right, so I hope that is clear at this point. These are very interesting questions to learn about. All right, okay. I'm going to move on to the next question shortly.